This is the presentation of my research on convolution reverb. So in this presentation, I'm going to go a bit more into detail about some of the aspects I covered in the essay. So to begin, first, convolution can be defined as the altering of a signal using the characteristics of another signal. And example of this, a similar example would be FM synthesis, the modulation of an oscillator modulating another oscillator to synthesize a wave. Although in that sense we're talking about waveforms, here we're talking about signals. And further, talking about impulse responses. So there's a couple of cool diagrams of impulse responses. I chose this one of a impulse response being recorded in a concert hall, and a few details about that. So the concert hall, as you can see in the image, it includes very meticulously the steps and the chairs inside of the concert hall. The article said that this is not totally necessary, but the more detail that is put into this kind of digital recreation, the output will be more accurate of what the recorded sound would, the signal would sound like being recorded in that space. And furthermore, the whole concept of convolution reverb is adjacent to the study of algorithmic reverb, which is the mathematical, basically, creation of reverb using algorithms that map the reflections of sound inside of a space and matching those reflections digitally, so that not impulse response isn't even needed to be recorded inside of the space, but instead it can be replicated digitally through the mathematical algorithms. So I thought that was pretty interesting. Further, through the process of convolution reverb, I thought the multiplication of the impulse response is very interesting. So this is sort of where the math side of it comes in. So the multiplication of the input signal and the impulse response, it emphasizes the areas that are similar, the frequencies that are similar in the two recordings. So as if it was being recorded in that space, just as if it was, say, a trumpet player was playing in that space, the frequencies would be complemented. Some frequencies would be complemented, some would be canceled out. So this mathematical kind of replication of that allows the initial signal to sound just as if it were recorded in that space. I also wanted to play an example of an impulse response. There are a few examples online that say you can do a gunshot or a balloon popping, but the most popular one, and seems to be the most, I guess you could say, accurate one to use, best one to use, is of a sine sweep. So I found this recording of one. Won't let that get too high, but basically goes through all the frequencies, and by doing this you could see how the space's atmosphere responds to each of those frequencies, which produces a very accurate output after the processing of convolution reverb. Also, the digital plugins that are available today are very high quality, and they've been developed throughout the years to be super accurate, and they're often used inside of movie studios for recording movie lines, because nowadays a lot of these movie studios and production spaces are digital, green screens, CGI, stuff like that. So they don't have the actual acoustics of the space because it's digitally created. And using convolution reverb allows them to add a sort of depth to the lines being spoken, as well as the sound effects. And this adds to the movie's whole immersion, because it sounds like the characters are inside of this digitally created space, even though it's digitally created and that's possible. So yeah, so that's just a few of the aspects I found pretty interesting. I thought I should add more detail to those. And yeah.